A website on AWS, and our speaker is Robert Shu, Principal Tech Evangelist for AWS. Hope you all learn a lot today, and take it away, Robert.
All right. Sound check. Everyone in the back, can you hear me okay? Yeah? All right. Before I begin, I must tell you that we've been having some networking difficulties. The Wi-Fi at the conference is a little bit spotty, and we've had some trouble. Now, because this entire talk is about building a website, you can see how that introduces some problems. I'll do my best, but we are at the mercy of the demo gods, well, specifically the Wi-Fi gods today. So I apologize in advance. Let's see how far we can get. Okay. Building a website, that's a broad topic. So I'm going to give you an anti-agenda right now. Because I can't cover everything in 45 minutes. So instead of following anything, these are the topics I'm not going to cover. And if you were hoping that I was going to cover this content, I apologize. I won't be offended if you want to leave and check out a better session. But I'm not covering HTTP, HTML, CSS, JavaScript, APIs, databases, mobile progressive web apps, or the Game of Thrones ending. Okay, what is the hardest part about building a website? Anybody shout it out. What's so hard about building websites? Speak up. All I hear is murmurs. Anybody brave enough to shout something out? Design, DevOps. Where to start? Yeah? Okay, I think those are all really tough challenges. But there's one that gets me every time, and that's picking a domain name. I was trying to get this domain for this demo, legit.business, because I know we have a startup crowd here. I couldn't think of anything cheekier, so I tried to get legit.business. No luck. I was frustrated, so I took to Twitter. And my colleague Ian was helpful enough to suggest, well, okay, you can't take legit.business. How about dodgy.business? Good suggestion, Ian. Taken. But it's often when we're at our most desperate hour that inspiration strikes. So I changed just one letter in this domain, and I succeeded. Doggy.business. Thank you. Good enough, right, Ian? Okay, so V1, let's try this out. Okay, by show of hands, how many people here use GitHub? All right, that's almost everybody. And that's great, because I always like to start with the simplest possible thing that could possibly work. And since everybody here, almost everybody here, anybody here not a GitHub user? Not a GitHub user, okay. I'm going to show you exactly how this works. Don't worry. You can go sign on. It's really easy. This is one of the simplest and most widely used features on GitHub. But there's a feature on GitHub called Github Pages. Anybody use that? Yeah, Github Pages. Okay. And what it allows you to do is to turn your GitHub repository into a static website. Let me see if I can get that working for you real quick. At this point, it's almost better if we get the no internet thing so I can play the dinosaur game while we're waiting. Thank you for your patience. Okay. All right, let's go and create a new repository. We'll call it Doggy Business. And oh, I'm sorry. No, we're not seeing anything. We're just seeing a desktop. Okay. Can everybody see that in the back? Okay. Sorry about that. Yeah, if there's any other technical problems like that, please feel free to raise your hand. Okay, so all I'm doing is coming into GitHub right now, and we're going to create a new repository. And I'm just going to call it Doggy Business, because that's our domain name. And I'm going to leave everything else as default. Going to make a public repository. Okay, so I'm going to copy the GitHub URL right here, the Git repo URL. And then I'm just going to come in here into the command line. Let me. It's not that interesting. I know if you can't see it, it might be hard to follow. But I'm just going to git clone that repo. And it's just told me that I appear to have cloned an empty repository. Of course, I should expect that. I haven't put anything in there yet. And now what I'm going to do is I'm just going to put the simplest possible HTML file in here. So let's say oh, it is really slow. I'm just going to put that as an h1 tag. I know those astute among you know that this is not legal HTML, but I'm taking advantage of how forgiving modern browsers are, so this should work on most browsers. And then I'm going to just git add. And I'm going to push to the repo. Now notice nothing I'm doing so far has anything to do with AWS. I don't even know why I'm giving this talk in the AWS booth. Okay, so we have this index.html file, this amazingly well-crafted web page that I just built in 5 seconds. Now, if you have this GitHub repo in this state, you just have static HTML, JS, and CSS assets at the root of your repo in the master branch. You go into your repo, you click Settings, and then you scroll down to this section called GitHub Pages. And as you can see, it says it's designed to host your personal organization and project pages from GitHub. So you click here, and you say, I want to use the master branch for my GitHub page. That's all it takes. And you see what it did? Can you guys see in the back over there? Yeah. So there's this GitHub page URL. It's my GitHub username .github.io / the repo name. And sometimes these static page URLs take a little bit of time to propagate. But there we go. I have my HTML file displayed at a URL that any of you can access, conference Wi-Fi networks permitting. So that's the easiest thing that could possibly work, right? I mean, what's wrong with this? Right? Like, why not just use the simplest possible thing? Well, first, I want to point out one thing. That URL isn't the URL that I bought, isn't the domain name that I bought, right? That URL was myname.github.io / doggybusiness. And what if I want this elegant user experience where my customers don't have to remember a github.io URL? There's another setting under GitHub Pages where you can go and put a custom domain name, and in your domain registry, you can go and configure a DNS record to point to the IP addresses of the GitHub name servers. And now that works, okay? But that has a drawback. Anybody tried that before? Custom domains for GitHub Pages? Yeah, okay. So the problem with that approach is that GitHub will generate an SSL certificate for your custom domain, right? And so if you want to direct the root, the apex domain, doggy.business, to that URL, and GitHub controls your SSL certificate, you can no longer use that certificate to go and redirect different subdomains to other services that you might want. Or at least, it's a huge pain. Did we just blank out in the back? Okay, let me remirror this thing. Folks, I apologize for all the technical difficulties. Okay, but there's another simpler reason why we can't use GitHub Pages. This is the GitHub Pages terms of service. GitHub Pages is not intended for or allowed to be used as a free web hosting service to run your online business, e-commerce site, or any other website that is primarily directed either to facilitating commercial transactions or providing commercial software as a service. If we're here to make money off of Doggy.business as our new startup idea, GitHub has just struck us out. Not going to work. Some other reasons to not use GitHub Pages are that there are arbitrary bandwidth caps. And by arbitrary, I don't mean low. Actually, GitHub Pages has a very, very high bandwidth cap. But the problem is that there is no terms of service with you, the customer, right? They can change that cap at any time, and they have no obligation to inform you. You have no control over the CDN. You have limited control over SSL. I mentioned that earlier. And if you have applications that are transpiled, so let's say you want to write your web application in TypeScript, or you want to build a React or an Angular or a Vue app, those applications cannot be natively interpreted by the browser due to their markup nature, right? So they need to be transpiled. And if you transpile them into vanilla JS, now you need an extra step. And how does GitHub Pages handle that? Well, you're not committing build artifacts into your repo. That would be a bad idea, right? Of course. No, instead you're creating a branch to host your build artifacts, and you push to that branch, and you point the GitHub page to that branch. So I think my point is that at this point, it's very clear that GitHub Pages is no longer the right tool for the job. With me so far? Okay. So what do we want? What is the shape of the problem? Well, what we really want is that really handy feature of just taking a bundle of HTML, JS, and CSS and putting it somewhere, right? Just having that available, having high bandwidth, having metered pricing, transparent pricing, having clear terms of service for what I can and can't do with the resources that are served out of that location. And for that, AWS has just the thing. How many people here have used Amazon S3? Okay, a couple hands, but it seems like most of you haven't. S3 stands for Simple Storage Service. And with S3, we can basically treat it like Dropbox. We just dump some files in there, and we enable a button, just like we did with GitHub Pages, and we get a static URL, just like GitHub Pages. Let's try to do that right now. I'm going to log into my AWS console. And then I am going to find the S3 service. I am going to hit Control-R. Oh, okay, it's back. All right. Create bucket. I'm going to call it doggy.business. What? Is it here? I don't see it. That was very weird. It told me that it existed, and then I refreshed, and then it didn't exist. Okay, well, internet problems, right? Okay, so we have this doggy.business S3 bucket, and now I'm going to grab my awesome index.html file, and I'm just going to drag it into this bucket and click upload. I have now successfully uploaded my fancy web page. And then what I'm going to do is enable static hosting. Now, it's currently disabled because there's this setting here under the permissions tab where I've blocked all public access. And while I have to go and change this, this is actually a good idea, right? Because it's saying that any S3 bucket you create by default is going to be secured so that nobody can have access to it. And you need to make an explicit decision about where, when, and how to grant access and who has access. So since we want to grant access to anonymous users on the internet, I'm going to uncheck this thing and then click Save. And it's telling me, hey, that sounds like a bad idea. Are you sure you want to do that? Yes, I'm sure. And then I have to come into the bucket policy. Now, if you've used AWS before, this is going to be familiar to you, but this is our identity and access management policy editor. And in this editor, I'm going to author a document that says who can have access to this thing, right? Because all I did with the public settings in the other tab was to say, I want to make that even possible, but now I'm going to specify the exact permissions. So to save me some typing, I'm going to paste this thing. And then you can see that almost all Amazon resources have this thing called an ARN. This stands for Amazon Resource Name. This is a unique identifier to help you unambiguously address the thing that you created. And in this case, this is the ARN for the S3 bucket that we created. And notice that I've left this bucket name here, so we're just going to paste this here. Now, what we're doing here is we're saying we're creating an identity and access document which contains one statement. The effect of this statement is to grant access. It's to allow access. Who is it allowing access to? That is identified by the principal. And by specifying a star as the principal, I'm saying it's granting access to everyone. What am I granting everyone access to do? I'm granting them access to perform this action, the get object action, on an S3 bucket. What resource does this apply to? The resource that I just created. Okay? And I'm spending a lot of time on the identity and access management piece because I think it's critical to securing your infrastructure. So now this bucket has public access. There is one last thing I need to do. I need to come in here into properties. Let me refresh this. I believe there's some caching problem going on. Because normally after we save this bucket policy, we should be able to create a static URL for this bucket. Just bear with me for a moment. Okay. If the internet is not behaving within the next 30 seconds, I'm going to proceed. Unfortunately, I don't think the demo is going to be nearly as compelling. Thank you again for your patience. Okay. Back to the slides, and unfortunately, I'm going to have to narrate what you would have seen if we had had internet access. You can imagine it's a little difficult talking about building websites without internet access. This was the S3 bucket that we had just authored, the policy that we had just set. And what I was going to show you is that after we host it at the static URL, we do have access to all those HTML, JS, and CSS assets, but it's at a randomly generated URL, right? It's some bunch of garbage dot, S3 US East dot Amazon.com, something like that. That's not the URL you want to give your customers. We actually just want to give our customers our doggy.business URL. And so the other thing is that we want to give our customers some assurance that they can trust the site. We don't want traffic going over regular plain text HTTP. And in other words, whenever customers visit our site, they want to be able to see that padlock icon. Let me see if I am having any luck now. No. Okay, so imagine, if you will, that we had gone into Route 53. We've gone into the hosted zones for our doggy.business domain. And we want to point something to an IP address, right? But we don't have an IP address. We have a static S3 bucket URL. And this is where AWS is kind of cool. In Route 53, for your domain management piece, you can actually connect it directly to your static S3 bucket via Route 53 as an alias in your DNS records. This is a unique feature in Amazon Route 53, which is our DNS management service, right? It allows you to connect to different services to route requests that would otherwise be routed to hard-coded sets of IP addresses, but it just hides all of that under the covers and it gets the request to where it needs to go. But when you want to add an SSL certificate in front of your S3 bucket, that requires one extra step, which is a CloudFront distribution. Now, CloudFront distribution is a deployment across our fleet of edge locations for our content distribution network. What that means, and I'll show you shortly, is that your content is going to be pushed to different locations all over the world and served out of the location that is closest to the customer's originating location, therefore providing them maximum performance. And in order for the CDN to work, we need to assign an SSL certificate. So let me show you, okay, well, let me back up a moment. I'll get to the SSL certificate shortly, but the first step I want to talk about is how does DNS work? Now let's assume that we had successfully issued a request to doggy.business or any URL. What's actually happening behind the covers for DNS, the domain naming service? Well, a lot of people like to think of DNS as the phone book for the internet. And that's a very powerful analogy. It goes a long way. Because imagine if you want to call your friend Andrew, but you don't have his phone number. You can't just tell the phone company, call Andrew. They don't know what to do with that, right? So you need to look up what Andrew's phone number is. Your device doesn't know. So you might go look at Andrew's different social media profiles. You might Google Andrew's name. You might go to a phone book if you have one of those these days, right? And then finally, you might ask Andrew himself when you see him next time. You're like, hey, what's your phone number? I don't have it in my phone. So Andrew is actually the authoritative source for what his phone number is. If he doesn't know, then nobody knows, right? And so it is with DNS. Actually, you'll see shortly that DNS also has an authoritative record for what the IP address for a given domain is. Now let's say you open up your browser on your laptop and you type in www.example.com into the browser's address bar and you hit enter. What happens? Well, that's actually not the full URL. There's an invisible dot at the end of the address. And that invisible dot will become important shortly. The first thing that your computer is going to do is perform a forward lookup. A forward lookup is the name of the DNS operation that resolves a URL, a domain name, into an IP address. And so it issues this forward lookup to something called a DNS Resolver that is usually run by your ISP. Okay? And the DNS Resolver is your agent. The DNS Resolver is going to help you answer this question without forcing you to go and ask any other servers, any other entities. So the DNS Resolver doesn't know either. It doesn't know what the IP address for www.example.com is. But it says, I know, I'm going to ask the root server. The root server contains the records for the dot at the very, very end of the URL, because the URL is going to be resolved backwards. So it asks the root servers, hey, where are the records? What is the address for example.com? And the root server says, you know what, I don't know. But I know who has the records for all the URLs ending in .com, the .com top-level domain. So it replies to the DNS Resolver, and it says, here are a list of IP addresses for you to connect to the com dot top-level domain servers. And then the DNS Resolver will connect to one of those servers. And the com dot server doesn't know either. It doesn't have the records for example.com. So the com dot server is actually going to redirect you, to redirect the resolver one last time. And it's going to say, I don't know, but here's the address of the server that contains the records for example.com. And example.com is going to be the authoritative name server. But this name server is usually your domain registrar. So if you had chosen Route 53, this is a server that's run by AWS. If you had chosen GoDaddy, it's a server that's run by GoDaddy, right? So that might raise the question, well, who owns these other name servers? And I did a little bit digging, but it turns out that VeriSign is the company that owns all of the .com top-level domains. So if you're dealing with a .com URL, you're dealing with VeriSign, right? Who owns the dot at the very end of the URL? Well, that's a number of organizations. It's actually 13 different organizations, including the ISC, ICANN, NASA, University of Maryland. There's this really cool tool called rootservers.com. You can go and you can check out all the traffic and how busy the different root servers are. And so once the DNS Resolver has the final address, the IP address, it finally has what it wants, the IP address associated with www.example.com. Now, it's going to cache it away. So the next person to ask that question, they don't need to go through this process again. It just has the answer ready to go, and it just gives it back. Now, all of these records have what's called a TTL field. TTL stands for time to live. And the time to live tells the DNS Resolver, hey, do not keep this record in your cache for more than this amount of seconds. So if the TTL is 60 seconds, the DNS Resolver knows that after 60 seconds, I'm going to evict this address record for this domain, and I'm going to go through the process all over again. Because otherwise, it could be stuck indefinitely with an outdated record, right? And consequently, this is why when you go and change a record in your hosted zone, in your domain registry, it takes a little while to propagate, right? You see that message that's like DNS propagation could take up to 48 hours. That's because one of the default TTLs is 1 hour. And if you wait for 1 hour to propagate tier after tier after tier, that adds up. And you just don't know how long it'll take. So to err on the side of safety, your domain registrar will tell you, wait for up to 24 to 48 hours before you call us on the phone, right? So that's DNS in a nutshell. And why am I telling you all this? Well, I think, it's very easy to get carried away with how easy it is to build stuff on AWS. Because you can get up and running so quickly. But if you consider yourself a technical person, if you're a builder, it's really in your best interest to dig a little bit deeper and understand just what it is that AWS is doing for you. Now, I don't mean go deep in every single case, go all the way to the bottom, go all the way to the instructions on your CPU. I mean, explore up and down the stack a little bit so that you have a good idea of what's happening, because it means that if something goes wrong, you're better equipped to handle it, and you also know how better to navigate the services that we offer. Okay, the next thing I mentioned was HTTPS. And once the browser has resolved the IP address for a given domain, then we can start issuing HTTP requests, right? But it's 2019. We should not be issuing HTTP requests over plain text. We should only be performing HTTP interactions with servers that are secured using TLS. So first off, a little bit of vocabulary, because HTTP, SSL, TLS, the terms get tossed around a lot. HTTPS just stands for HTTP secure. I know it's a very weird way to say it, but SSL stands for Secure Sockets Layer. And this was a security protocol created by Netscape to enable commerce in the wee early days of the internet. And since SSL was so critical to conducting business transactions on the internet, they changed the name to TLS to avoid any sort of concerns with Netscape being acquired by AOL, blah, 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 right? So we have TLS. And these days, almost nobody uses SSL. It's just TLS 1.0 through 1.2. So you might wonder, well, what exactly does HTTPS get you? And there are two categories of benefits. The first is that you get a bunch of functional benefits, specifically identity, confidentiality, and integrity. Identity means that you know that the server is who you think it is. Otherwise, they can change the IP address out from under you. They can point the DNS record to a different IP address, and you're not sure you're talking to the same server anymore, right? And if you're talking to bankofamerica.com, you want to know who you're sending your bank information to, right? So the first thing that HTTPS does is let you know with a high level of confidence who you're talking to, and I'll show you how shortly. The second thing is confidentiality. Once the HTTPS channel has been established, the HTTP traffic that goes over that channel is now confidential. That means a third party cannot arbitrarily snoop on that traffic. They can't read what's going on. The messages to them appear to be garbage. And they also cannot tamper with these messages so that they can kind of deny your ability to communicate with the other party. And that's the integrity part. But even if you don't care about any of these things, you should still care about HTTPS because there are two critical non-functional capabilities that it grants you. The first is just user trust. A lot of people have been trained to not enter their credit card information unless they see a padlock icon in the browser. And that's actually pretty good advice, right? You should not be sending your credit card information over plain text. So it creates user trust. A lot of users will just not use your site or will not conduct financial transactions unless they see that it's over HTTPS, even if they don't understand exactly what that means. The second is that search engine optimization now takes HTTPS into consideration. So your search rank on Google will actually vary depending on whether your site has been secured with TLS. Now let's take a look at how exactly this works. On the left, we have our browser, and on the right, we have the server with the IP address that we fetched from performing a DNS resolution, right? And to start, again, we have example.com, we went over that. We have the IP address. So the first thing is that we need to secure this TCP session. And so the client sends a special message, literally called client hello. And client hello also includes a couple of other things. It includes a timestamp, it includes a bunch of random numbers that we're going to use later, and includes the set of cipher suites. These are the cipher algorithms that the client's browser is capable of using. The server takes a look at all this data, and it says, okay, I can use one or more of those cipher algorithms. I'm going to choose the one that I want to use, and I'm also going to send back to the client my timestamp, my random number, and the X509 SSL certificate that contains the server's identity. And this is the certificate that you can get issued from Amazon Certificate Manager automatically. Upon receiving the server hello, the client is now going to authenticate the certificate. And how it does this is that each certificate, it has some claims about the subject. So for example, it's saying this is example.com, but it also has a very critical claim, which is an issuer, which is who issued this certificate. And that certificate also has an issuer, and on and on and on, until you get to what's called the root certificate authority. And so what this does is create a chain of certificates on the client machine. And if any one of those certificates is invalid, if it's expired, if the signature doesn't check out, then the client fails the authentication process, and it says something fishy is going on here. I cannot trust this particular transaction. And so it bails on the HTTP session establishment. But if everything checks out, then the client and the server, or the client sends back a pre-master key to the server, okay? With the pre-master key, now both the client and the server have three effectively random numbers: the pre-master key, the client random bits, and the server random bits. And using a fancy mathematical function, it combines all this stuff, and it gets what's called a session key. And both of these, with these three inputs, it gets the same output. So now it has a session key. And it uses this session key to perform symmetric encryption on all traffic going across the session from here on out. And now, anybody who does not have the session key does not know what information is being transferred. It does know that information is being transferred, but it cannot read any of it. With me so far? Okay, so that's SSL in a nutshell. Now, I also mentioned that we needed to create a CloudFront distribution in order to get SSL working. But what is CloudFront? CloudFront is a content delivery network that's capable of caching and serving requests to your website at a variety of locations across the world. here's a map of all of the CloudFront cache locations. In total, there are 180 points of presence. These are just physical locations where we can cache your data. 169 of these are what we call edge locations. In other words, they're not associated with one of the AWS regions. The other 11 are called regional caches. As their name implies, they are associated with one of the AWS regions. And CloudFront is part of the Amazon Global Network. The Amazon Global Network is the most sophisticated and extensive public infrastructure network available. It has the largest footprint of any public infrastructure network. And it consists of all of the AWS regions, their availability zones, and all of the CloudFront edge locations that I just mentioned. You can learn more about the Amazon Global Network at infrastructure.aws. There's some cool visualization tools. So what does a CDN do for us? Now let's say that we're here in Toronto today, and we're going to communicate with our server in Oklahoma City, right, in the bottom left. If I issue a request from a client in Toronto, that request, knowing DNS, knowing SSL, all this stuff, now, it's still going over TCP/IP, which means that that request is going to be subject to routing behaviors from all sorts of public infrastructure providers, right? It's going to be subject to that for the ISP provider that I'm choosing, the mobile network operator. So this request may make a number of hops before it gets to the destination. And what this means is that for my users, the latency and the variance of that latency is going to be high. The more hops, the higher it is. In fact, this visualization oversimplifies it. It's very normal to have your packets go through 20 or more hops in order to get to your destination. And this matters a lot because each hop, there's physical distance. That packet is going over a fiber connection somewhere. And then once it gets to the router, it has to be parsed and it has to be routed. So that's all time. And this matters. Anybody here a gamer and play video games? You don't want to play on a server that has really high ping, right? Because that's just not fun. You want to play on a server with really good ping. But you don't get really good ping unless your operators have optimized the route that your packets take. And a CDN can help you do that. What does the CDN look like? What does the picture look like when we have a CDN as part of this equation? Again, our originating location is Toronto. If we have a CDN edge location nearby, our packet goes there. I mean, while the packet is in transit to the CDN, it may take several hops, so bear in mind this is a simplification. But at that point, it's on the Amazon Global Network. That packet is now traversing across custom hardware, dedicated fiber lines, spare bandwidth capacity, custom routing infrastructure. In other words, that packet is going to get there as quickly as possible. So here's a logical diagram of what happens when you build a CloudFront distribution. You're actually saying, look, all over the world, Tokyo, New York, Madrid, London, in these edge locations, create a little folder for me. And anytime there's a customer near that endpoint, route that customer to that endpoint, and then fetch the resources from my origin, my static assets, my index.html, my styles.css, my JavaScript bundles. Fetch those from the origin, the static S3 bucket. And then once you fetch them, cache them away. Hold on to them. They're static assets. They won't change, right? And serve them out of that edge location to this customer and other future customers that ask for that same resource, serve it right out of the cache. Don't go to the origin. And that means that you're not even making the round trip back to the origin. You're serving the content at maximum speed from an edge location co-located with your customer. Now, the astute among you might notice that when we deploy a cache, we actually have a cache invalidation problem, right? What happens if you go and change index.html? And a customer hits the Tokyo server. The Tokyo server says, I don't need to go consult the origin. I have the answer. Here you go. It's an old answer, right? And this is one of the trade-offs that you get with a CDN. You have a cache coherency problem. But there are common strategies to deal with this. For example, if you're building applications with any sort of JavaScript framework, you know if you inspect the output directory that all the static assets have the common names for humans to read, but then they have some GUID attached to them, which means that that static asset has a fundamentally different URL. So when your clients request the static asset, if they request the old static asset, well, that's cached, and that's correct. But if they request a new static asset, that's a cache miss at the CDN. And the CDN will now go fetch that asset from the origin. So it's not a free lunch. There are problems to work around with cache invalidation and cache coherency, but there are commonly tested, well understood solutions for cache busting. The second thing I want to point out about CloudFront is that it supports a programmatic API that allows you to invalidate the cache. That means instead of waiting for this client to say, hey, I want this resource. Oh, I don't have it. Let me go ask for it. You can proactively say, hey, I know there's been a change on my backend at the origin. I want to flush all of the cache data across my entire CloudFront distribution. And you can do that with the click of a button. Now, everything I described with CloudFront works primarily for HTTP. But again, those of you who are gamers, you know that your favorite games don't just work over HTTP. They don't typically work over HTTP at all. They work over TCP or UDP. And if you want to have what is the effective equivalent of a CDN for arbitrary TCP, UDP WebSocket traffic, you need a slightly different service. It's called Aws Global Accelerator. I don't have a lot of time to go into depth, but the fundamentals are the same. Again, it's finding an edge location so that you can traverse across the Amazon global network for as much of the duration as possible, especially if you're building video games. This is going to streamline the ping times that your customers experience. So happy to talk more about that offline. And with that, that is all I have. Thank you very much for joining me. Again, I apologize for the internet troubles, and I look forward to meeting you and speaking with you offline.